Okay, it appears I'm good at the moment and it's running.
Good, yeah.
Okay, this looks like it's artificial here. It looks like this is not a real rock. You know, this is something that some kind of concrete. It isn't. This is a conglomerate. Locally, it's sometimes called Potomac marble. It's not a marble. It's actually a sandstone. The sand is in between the pebbles here, and it's reddish. This is what a geologist would call a red bed conglomerate. And the rocks themselves are very angular, sharp edges. Not extremely sharp, but they're not all rounded. So it hasn't traveled very far. Obviously, though, there was some heavy topography around here. You know, this was rough country. This was not Mississippi or Louisiana. This was more like Colorado. There was a cliff nearby here. And actually, we know where the cliff was because we are now in a rift valley here. It's actually not quite a full graben. Graben has faults on both sides. It's like the keystone of an arch where you pull the arch apart. And I'm going to wait a minute for these cars. Okay, if you pull the arch apart, the top stone will drop down. That's how a graben works. Okay, in this particular case, only one side dropped down. It's what's called a half graben, but it works exactly the same way. And this happened when the supercontinent of Pangaea was pulling apart about 100, 200 to 180 million years ago. So these rocks came from the cliff side of the half graben, which was right over there. That's the edge of the Blue Ridge right over there, and there's a major fault right along the road there where one side dropped down probably a few thousand feet. Now, here's the problem though, and it really is a problem. The rocks on the other side of the fault, which we'll get to see when we get up to that road there, US 15, is greenstone. It's metabasalt, Catoctin greenstone. Wait a minute, if the cliff on the other side was made of greenstone, there's no greenstone in this. Where did these rocks come from? Okay. This is towards the bottom of this column in the graben. Most of this has been eroded away, and most of the filling on the graben is gone. And when a whole bunch of traffic coming. Okay. When this valley had first started to form, the rocks on the other side were these rocks. It was limestone and quartzite. It turns out that what happened then was that the rocks kept going up and up and up, and lower rocks were exposed over here as this side went up and this side went down. Now we're looking at the really low down rocks, which is the greenstone. The rocks that were at the top originally are all eroded away. The only place we can see them is where they drop down into the valley, and that's what we're seeing here. Now, if you look at those rocks over there, and we won't stop, but we'll see them as we go by. They're dark greenstone. If you look at the sequence of rocks over there, you find out that over the greenstone, you find quartz sandstone, which is in here, and over that, you find limestone. That's what was up at the that's all gone now. It's all eroded away. But the trace of it is still left here in what used to be the valley. It still is a valley, but now it's Now it's just a very low valley. If you were here 180 million years ago, that cliff over there, that hillside might have been a mile or two high, because this is the equivalent of the Owens Valley in California, which is 2 miles below the mountains on each side, which is the upraised side of the Rift Valley. Owens Valley is the downdrop side. Okay, let this last car go by. Interestingly enough, I've never seen this discussed in any paper. Somebody may have done this as a master's thesis, looked at the sediments in the valley and tried to figure out exactly where they came from and how it varies from place to place. If they have done it, I've never seen it. And if it hasn't been done, that'd be a wonderful master's thesis for someone. It would be very easy to do. All you have to do is find all the places where this rock is exposed, and that would be easy because the mapping has been done in this area, and that you can look at the map and find out where the rock is exposed. Go out and check the rocks present in the conglomerate and check how it varies from place to place, and you'll have your master's in geology. Now, one of the nice things about geology is that there are so many more problems like that than there are students to study them. Okay, let's go see. Well, they still won't be quite open yet, but they'll be open in a few minutes. There is a little bit of calcite.
Hold on, okay.
There's just a little bit of calcite in the red sandstone here. It does fizz, but not nearly as much. Whoop. That one didn't fizz at all. That's not calcite, not limestone. That one isn't. That one isn't. That one is. That fizzed like mad. That one fizzes some. So these are different rocks from different places. Whatever was exposed on that hillside over there when this valley was first forming, which isn't the rocks, as I say, that you see there now. The rocks that you see there now are greenstone, metabasalt, and that was not exposed when this valley was first forming. Might mention, by the way, that these rocks on either side, on the Blue Ridge and over on the Sugarloaf Mountain side, those rocks are folded. They're faulted and folded by the assembly of Pangea. That is the approach and collision of Africa with North America, which resulted in the folding and the faulting of the rocks that got caught in between. So if you were here 250 million years ago, you would have been standing right in the middle of a very, very high mountain range here. The highest mountains would be off to the east, but the mountains were here as well. Off to the west, the rocks had been pushed down by the weight of those mountains, and we had deposition of sand and clay in the valley in front of the mountains, very much like the Himalayas today and the Ganges Valley just to the south. The Ganges Valley is filled with about 20,000 feet of sand and clay because of the weight of the Himalayas, and the same thing was true here. So that was the assembly of Pangea, and this valley in here, the Rift Valley, recorded in this conglomerate, records the disassembly of Pangea, when it broke apart into Africa and Europe on one side and North and South America on the other, opening up the Atlantic Ocean. So you're looking at the genesis of the Atlantic Ocean here in this rock. This particular valley stopped opening up There were a whole series of those valleys, if judging by what we can see today in equivalent places. One of them is now the Atlantic Ocean. This one stopped growing.
I think they're inside.